Okay, today we're going to learn about rotations. We learned about translations first in 8.1, then we learned about reflections in 8.2. Today we're going to learn 8.3, which is rotations. We use a capital R for reflections, but with rotations we're going to use a lowercase r. So whenever you see a lowercase r, you're going to know that's rotations and not reflections. Then underneath the R in parentheses, you will see two things. The first number you see will be the degrees, and that's how far you rotate. The second thing you'll see, point of rotation. So most of the time it'll say O. That means you're going to rotate around the origin. So one more time. The first number is the degrees you rotate. The second number is where you're rotating around. When you're rotating, rotate counterclockwise at all times unless you are told to do otherwise. Okay, first problem we're going to do. Rotate triangle BRD around point P. We need to know what we're rotating around and how far we're rotating around it. So they say point P, which is right here, we're going to rotate 180 degrees. So the best way to go about this would be to just look at the 3 points, B, R, and D. Let's focus on B first. I'm going to create a right triangle from the point of rotation to the first point. Here is a right triangle. If I'm going to rotate 180 degrees, that means this line, if I were to put it here, so this would be 3 units to the left. If I went 3 units down, this would be a 90-degree rotation. So I want to go one more. This would be a 180-degree rotation. So now my right triangle, notice that this is 3 units long, the base, so the base needs to stay 3 units long. The height of my triangle is also 3 units, so I'm going to go this way, 3 units. So I have just created a right triangle that's been rotated 180 degrees around point P. This is now B prime. I'm going to actually make that red and erase the triangle so we can start over with the other 2 points. Okay, so now I'm going to try point R. I'm going to again create a right triangle with the point of rotation. And I'm going to rotate this triangle 180 degrees counterclockwise. So right here is a length of 1, 2, 3, 4. If I go this way, 1, 2, 3, 4, that would be a 90-degree rotation. So if I go one more, 1, 2, 3, 4, that would be a 180-degree rotation. Now on this one it's a little tricky because you're rotating this direction. So I know my height is 1, 2, 3, so I'm going to go up this way, 1, 2, 3. The point right here is R prime, and I'm going to erase all of my other pencil markings. Okay, so far I've got 3 points, or 2 points. Now I need my third point, D. Last time I'm going to create a right triangle with my point of rotation. So this is a 2 by 2 kind of triangle here. If I go up this way, that is a rotation of 90 degrees. So I go one more. Here's a rotation of 180 degrees. So here's my 180-degree triangle rotated. So this point right here would be D prime. Erase my pencil markings one more time. So what I'm doing is I'm drawing a right triangle using the point of rotation and the point I'm rotating. Now I can connect my 3 points. So I have officially rotated triangle BRD about point P, and I've rotated it 180 degrees. So I've taken this 180 degrees to create that new triangle. Problem number 2. Construct the 270-degree rotation of the square ABCD about point P. So I need to find point P. It's right here. I'm going to take this square and I'm going to rotate it 270 degrees. If I do that, I'm going to go all the way around this way, and you are definitely welcome to go in that direction. But if you remember, a circle adds up to 360 degrees. So if I went backwards, it's kind of a cheat way to do it. If I go backwards 90 degrees, it's going to land on the same place that 270 degree is. So I'm going to actually rotate clockwise, which is opposite of what I've told you. But if I rotate 90 degrees, that's the same as rotating 270 degrees counterclockwise. So I'm going to do the exact same thing I did in problem 1. I'm going to start making right triangles with each point and the point of rotation. So A. If I take A and I rotate this direction 90 degrees, the base of A's triangle, 3 units long, I'm going to go down 3 units, 1, 2, 3. It's 3 units high, 1, 2, 3, so I'm going to go 3 units high here. So notice I've taken this triangle, I've rotated it 90 degrees. This would be point A prime. Erase my pencil markings. Now let's go to D. Since D is directly across from point P, it makes it easier to rotate it. So I've got a horizontal line here. If I want to rotate it this way 90 degrees, now I've got a horizontal line here. D falls right there, so I don't actually need to mess with a right triangle. So this would be D prime. Notice I'm already starting to see the square that's forming. We can go ahead and rotate C next because it's similar to D. It is right along the same line as point P. So if I take this line, which is 1, 2, 3, 4, 5, 6 units long, and I rotate it 90 degrees, 1, 2, 3, 4, 5, 6. So it looks like point C lands right here, so C prime. Notice this is still coming to life here, this square. And then the last one, you could either go ahead, try to rotate B, or I think most of you already know where B prime is going to land. Since this is a square, we can just go ahead and put B prime there. So we have just rotated square ABCD about point P 270 degrees counterclockwise. We didn't go in that motion because it's easier to just rotate it clockwise 90 degrees and hit the same place. You'll get into more complicated shapes. Number 3, we're going to graph figure FGHJ. Remember the 2 numbers that are given under the lowercase r. The first number is how many degrees you're rotating it. The second thing you see is where you're rotating it around. I don't see point O anywhere, so when you see O, that refers to the origin on a grid. So I'm going to be rotating it about this point, the origin. So I'm definitely going to use right triangles here to rotate this figure. I'm going to start with point F. We need to go 90 degrees, so it's starting here, 90 degree direction, 90 degree angle, we'll go left 90 degrees. I'm going to make a triangle if I need to. Since F is on the same line as the origin, what was a vertical line, when I rotate it, will now turn into a horizontal line. So all I have to do is count how long this line is, 1, 2, 3, 4, 5, 6. So that segment is 6 units long. I'm going to go this way, 1, 2, 3, 4, 5, 6. So F is going to land right here, and that becomes F prime. G is not right directly on that vertical line, so I am able to make a right triangle with the point of rotation. So this base here is 3 units long. When I rotate it, it's going to land 3 units down from the origin. The height is 2. That height kind of becomes the base now, so that's 2. So I've just rotated this triangle 90 degrees counterclockwise. This is G prime. Let me erase the triangles. Let's go with H. Create a right triangle again with the point of rotation and the point you're rotating. Okay, going 90 degrees. So this horizontal line now becomes vertical this direction because we're rotating it counterclockwise. So now it's going to go up here. The height was 1, 2, 3, 4. So now I'm going to go 1, 2, 3, 4. And this is H prime. One more point. You could go ahead and try to fill in that fourth point if you think you know where it is. I'm going to play it safe and just rotate the final point. J. So create a right triangle with J. I'm going to actually make my triangle look like this. I'm going to rotate it 90 degrees this way. So what was 1, 2, 3, 4 as my height, now it's kind of my base of my triangle. 1, 2, 3, 4. 1, 2, 3. That's going to be my new height. 1, 2, 3. So I've taken this triangle and I've rotated it 90 degrees counterclockwise. This is J. J prime. Now I can connect my red points to create my new figure. Okay. And that is F prime, G prime, H prime, J prime, rotated 90 degrees around the origin. Okay, you will get into questions that ask you to find angles of rotations when they don't tell you. So in this example, point O is the center of the circle, or of the figure, so I can label this point O. It's the center of the regular octagon. Octagons have 8 sides. Find the angle of rotation about O that maps F to H. So we want to know, how far do I have to rotate F so that it lands on H? In order for us to do this correctly, we need to remember that a circle adds to 360 degrees. So what I can do is I'm going to split this up into congruent wedges. And what that's going to do is it's going to help me figure out what's inside each of those wedges. What's the degree? What's the central angle of each of those? Well, if you remember, the circle adds up to 360 degrees. How many congruent pieces do I have here? 1, 2, 3, 4, 5, 6, 7, 8. So if I divide by 8, each wedge is going to be what? So 360 divided by 8. That'd be 4, 32, D5, 45 degrees. So this central angle is 45 degrees, 45, all around are 45 degrees. When you add them all back up, they need to equal 360. Okay, so now that we have our central angles labeled, how far do we rotate point F until it lands on point H? Okay, from here to here, we've rotated 45 degrees. Then another 45, then another, all the way to H. So 1, 2, 3, 4, 5, 6. We've rotated 6 times around this figure to land on H. And if each rotation is 45 degrees, then we do 6 times 45, which would equal 270 degrees. So it asks, find the angle of rotation about O that maps F to H. 270 degrees would be the angle of rotation. Last problem, very similar to the previous one. This time we have a hexagon though. Point O is the center of regular pentagon, a pentagon. Point O is the center of regular pentagon ABCDE. Find the image of the given point for the given rotation. Here, they tell us how far to rotate. You just have to say what letter do we land on. So before we do that, we need to split this up into congruent pieces. Again, I know that a circle is 360 degrees. If I make this circle here, I have to go through 5 wedges to complete that circle. So 360 divided by 5 would be 72 degrees. So I know each of my wedges would be 72 degrees. Okay, we're rotating about point O, which is in the center, and we're going to rotate 216 degrees. We're going to rotate A. So I'm going to start at A. Remember, you go counterclockwise. If I go all the way to E, I've only rotated 72 degrees. If I continue on to D, I've rotated 144 degrees. If I rotate one more time, that's going to be 216 degrees. So point C is where I land if I rotate point A 216 degrees around the origin. I have just gone through 5 questions that are directly pulled from a Math Excel assignment. So what I would like you to do now is log into Math Excel, open up 8.3's assignment, and I'd like you to complete that, and then you will be told what to do after that.